Today we're looking at special right triangles. These are triangles that have a shortcut so that you don't always have to use the Pythagorean theorem. You'll be able to look at the patterns for these special right triangles to find the missing side lengths involved. The first special right triangle that we're taking a look at is called the 45-45-90 right triangle. In your 45-45-90 triangle, both of your legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of that leg. So here's my generic right triangle showing isosceles right triangle because two angles are the same. I know two sides have to be the same. Those are both labeled as x, and the hypotenuse will be that number x times the square root of 2. So if I have a problem where the length of the leg is 8, I know the length of the hypotenuse is 8 square root 2. If the length of the legs are 23, I know the length of the hypotenuse is 23 square root 2. If I find the hypotenuse and I'm looking for the missing leg length, I'll have to work those backwards. So if I'm looking at a problem like problem number 1, I want to find the value of x. We're leaving that answer in simple radical form, so I'm just writing it with the square roots. I know that I have two angles the same, 45 degrees, so I have two sides the same. Those are both 17, and the hypotenuse has to be 17 times the square root of 2. So I'm done. If I look at question number 2, one of my angles is marked 45 degrees, the other is marked 90. Because a triangle adds up to 180 degrees, I know my other missing acute angle is also 45 degrees. Both of my sides are the same. Those legs are both 22, which means that my hypotenuse x is 22 times the square root of 2. I want to look at question number 4 before I go back to number 3. In question number 4, I'm given the length of the hypotenuse at 25 square root 2, and I'm looking for the length of one of the legs. I know that 25 square root 2 has to match to x square root 2, so pretty much by looking at it, I know that the 25 has to match with my x. So my x is 25. If I go back and look at question number 3, in this problem, I'm given the length of the hypotenuse is 8, and I'm looking for the length of the missing side. What I know about that hypotenuse 8 is that it is equal to the x times my square root of 2. In order to solve for x, I'm going to have to divide each side of the equation by the square root of 2. That'll give me x by itself equal to 8 divided by the square root of 2. And if I were just looking for a numerical value, some decimal approximation, that would be fine. I could divide it out and get an answer. But if I want to leave my answer in simplified radical form, like the directions say, that means I cannot have a square root in the denominator, the bottom of my fraction. In order to get rid of that square root in the denominator, I have to multiply by itself to make it the whole number 2. In order to keep my equation equal, I'm going to multiply this 8 divided by square root 2 by a fraction that's equal to 1. You know, anytime the numerator and denominator are the same, it's equal to 1. 3 over 3, 7 over 7, or in this case, the square root of 2 over the square root of 2. When I multiply fractions, I multiply across. 8 square root 2 is my numerator, and square root 2 times square root 2, or the whole number 2, is my denominator. I can now reduce that fraction because the 8 divided by 2 gives me a whole number 4. So x is equal to 4 square root of 2. So I've found my value for x. And I might want to double check that to see if I multiplied that crazy thing by the square root of 2, would I get 8? So I'm going to check. If I multiply 4 square root 2 times another square root 2, what do I get? Square root 2 times square root 2 is a whole number 2, so that's equal to 4 times 2, which is 8, and I've checked the fact that my problem has been solved correctly. On the back side of the page, I'm looking at the other special right triangle, known as the 30, 60, 90 right triangle. When I'm looking at the 30, 60, 90 right triangle, the length of the hypotenuse is twice the length of the shorter leg, and that longer leg, or medium side, is the length of the short leg times the square root of 3. So if I'm looking at my generic special right triangle, across from the 30-degree angle I have the length x, across from the 90-degree angle I have the hypotenuse 2x, and that squirrely side, that medium side, is going to be that x times the square root of 3. So in my examples, if I know the short side is 5, I know the hypotenuse is 10, and I know that medium side is 5 times the square root of 3. If I know the short side is 11, I know the hypotenuse is 22, and I know that that medium side is 11 square root 3. So as I'm looking at those problems, problem number 5, they want us to find the values of x and y. I know that this 18 is twice as big as my x. 18 is 2 times x. So I can figure out my x. It's 18 divided by 2, or 9 units. Once I know the short side, I can easily find that medium side, that longer leg, by taking that number 9 and multiplying by the square root of 3. And I'm done. I remember that these 30, 60, 90 triangles have a square root of 3 in them. Because there's 3 different angles, 3 different sides, it has a square root of 3. If I look at question number 6, they've given me the shortest side, so I automatically know my hypotenuse is twice that, 2 times that value of 2, or 4. And I know that that medium side, that longer leg, is going to be this number 2 times the square root of 3. I'm done. It's in simple radical form. If I look at question number 7, they've given me the length of the hypotenuse is 24 square root 3. I know that the short side x is half as much of that. Half of 24 would give me that 12. So 24 divided by 2 square root 3's is equal to 12 square root 3's. So the length of my short side x is 12 square root 3. If I want to find the value of y, it's my short side times another square root 3. And 12 square root 3 times another square root 3 means 12 times the whole number 3, because square root 3 times square root 3 gives me the whole number 3, and 12 times 3 gives me 36. The last problem is one of the more complicated ones because they're giving me that medium side or that longer leg of 33, and I have to work backwards to find out what my value of x is and then double it to find my value of y. So what I know is that 33 is equal to x times the square root of 3. I need to divide each side of that equation by the square root of 3, and that gives me my value of x. So x is equal to 33 divided by the square root of 3. But I shouldn't leave a square root in the denominator of my fraction. So I'm going to multiply top and bottom of that fraction by square root 3, square root 3 over 3. That's just equal to 1 by itself, but that will make my denominator be the whole number 3. When I multiply, I get 33 square root 3 for my numerator. Square root 3 times square root 3 gives me a 3 for my denominator. And I can reduce that fraction because 33 divided by 3 is 11 square root 3's. So my value of x is 11 square root 3's. I need to find my value of y. Y is twice as much as x. So I need to multiply 2 times 11 square root 3's. 2 times 11 square root 3's is 22 square root 3's. And I've got my value for y.